Hello, today I am going to be doing with you a review guide for advanced functions in modeling. This is our second test, and this is on quadratics. So we're going to be doing some quadratic formula, we're going to be completing the square, we're going to be factoring. Now, in these parts, it does say completely solve the following. We use a variety of methods. So that means we might be using all three of those. You might be just using quadratic formula for all of them. Technically, all of these could be solved with quadratic formula, but if you can factor something, it's always going to be fastest. But no matter what, all of these have to start being equal to 0. You'll see most of them are already equal to 0. This one's not, so we are going to have to move the 10 over. Same thing here, it's not equal to 0, so we would have to add x squared over there. But no matter what, when you start, it needs to be equal to 0. So just go ahead and then start this one. So the first thing I do is just see if it's like easily factorable. If it's easily factorable, then we'll just kind of be done pretty soon. But if it's not easily factorable, then maybe I'll try completing the square or quadratic formula. So things that would multiply to 48. So I look for things that multiply to 48 and add up to negative 14. So 1 and 48 would multiply to 48. 2 and 24 would. 3 goes into it 16 times. 4 goes into it 12. 5 does not. 6 goes into it 8 times. And then 7 doesn't go into it, and 8, we just get back where we are. So that's everything that would multiply to 48. So in this case, it does work out. These don't make 14, these don't make 14, but 6 and 8 does make 14. More specifically, when both of them are negative. So you get a negative 6 and a negative 8. And since those are just, this is a regular x squared, there's no number in front, you can go immediately from these, negative 6 and negative 8. And then when you set them equal to 0, just add 6 to both sides and you get 6. Add 8 to both sides and you get 8. And that's it. So because it was factorable, it goes pretty fast. If it didn't, then I probably would have completed the square or something. For number 2, as I said, it's not equal to 0, so you do have to add 10 to both sides. So you have 3x plus 11x plus 10 equals 0. And once again, you can try factoring it. You would do 3 times 10 is 30. Things that add up to 11 and multiply to 30. So that would be like 2 and 15 doesn't work. 3 and 10 doesn't work. 15 and 2. I'm not finding anything immediately. Maybe it is factorable, maybe it's not. I don't know. But nothing is immediately coming to mind. So I'm just going to go ahead and use quadratic formula because why not? Need practice with it anyway. So in quadratic formula, a is 3, b is 11, and c is 10. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So b is 11, meaning negative b is negative 11. B squared, I strongly suggest squaring b in your head, not using a calculator. That way you don't risk accidentally squaring a negative and getting a negative, because anything squared is positive. So 11 squared is 121. And then minus 4 times a times c all over 2 times a. Okay, so that's a negative 11 plus or minus. 4 times 3 is 12. 12 times 10 is 120. So 121 minus 120 is just going to be 1 over 6. You can take the square root of 1. It's just a regular 1. So negative 11 plus or minus 1 over 6, which then is negative 11 plus 1 over 6, or negative 11 minus 1 over 6. This will be negative 10 over 6. This would be negative 12 over 6. Which, I'm just going to put it over here. Negative 10 over 6 simplifies to negative 5/3. and negative 12 over 6 equals negative 2. Because these are fractions and integers, like there's no radicals, that means it was factorable. Like I said, I just didn't find them immediately, so I didn't feel like trying more. If you did continue to factor it, you would eventually get two things that get you those answers. So, over here on number 3, the first thing I notice is that 9, 6, and 24, all of them are divisible by 3. So you can make these numbers a lot easier if you just divide both sides by 3. Luckily, 0 divided by 3 is just 0 again, so that doesn't really do anything. And then 9 over 3 is 3. 6 over 3 is 2. And 24 divided by 3 is 8. So that simplifies it a bit. This one, I'll just go ahead and give it away. It is factorable. I could use quadratic formula again to get the right answer. I wouldn't use completing the square. Completing the square is only really useful if there's no number in front and this is an even number. Otherwise, it's just not worth the hassle. On the next page of the review guide, we are going to do completing the square because it says to. Over here, though, let's just go ahead and factor it. It is going to be a more complicated version of factoring because there is the 3 in front. That is where you do 3 times negative 8. And that is going to be the number that you multiply to. So negative 24 adding up to 2. So 1 and 24 would multiply, 2 and 12 would multiply, 3 and 8, 4 and 6, 1, 2, 3, 4, 5 does not go into it, 6 we already wrote. So this is everything that could possibly multiply to 24. And the only ones that could somehow get you 2 would be these ones. And then you would have to decide which, if any, are negative. In this case, 4 minus 6 would be negative 2, but 6 minus 4 would give you positive 2. So that's going to be a minus 4 and a positive 6. And unlike the first one where it's just those two numbers are the answers, because that number was in front, you do have to do a slightly different thing, where you take the middle 2x and you split it into those numbers, minus 4x plus 6x. The 3x squared comes down and the minus 8 comes down from here. Those are just the same as before. They just get brought down. It's only the middle term, 2x, that gets split up there. What that lets you do is to group these. If you group these and group these together, it is now factorable by grouping. In which case you're supposed to pull out a GCF. So between 3x squared and minus 4x, there's no number that goes into 3 and 4, but they do both have an x that you can take out. And when you do, you would have a 3x minus 4 left over. Here between 6 and 8, excuse me, 2 goes into both of them. So you can pull out a 2. And then you would have 6 divided by 2 is 3. And 8 divided by 2 is 4. Not so coincidentally, they turn out to be the same. They're supposed to. Your answer in terms of factoring would be x plus 2, because that's what's on the outside, and then the 3x minus 4 equals 0 still. And at that point, you can go ahead and set these equal to 0. So you would subtract 2 to get negative 2. You would add 4, and then divide by 3 to get positive 4/3. Not showing the work there, but it should be relatively simple. Add the 4, divide by 3. And there you go. That's number 3. Number 4, there's a couple of ways you can do it. I suggest factoring. Most people don't, and I'll show you why. Most people's first instinct is to plus 4, and that is fine. That is true. You get x squared plus 4. And then what people do is they square root both sides, and they say the square root of 4 is 2, so x equals 2. And congratulations, you get a 50% F on this question, because you have only found half of the answers. That's why I don't like doing it this way. What you did was correct, technically. It's just when you square root both sides, you have to put a plus or minus in front. And that's very easy for people to forget. So your answer should have been plus or minus 2, meaning yes, 2 was an answer, but so was negative 2. And if you miss that, then you miss half the answers, you get half credit. Otherwise, what you could have done is factor it. This is a difference of squares. Since the square root of x squared is x, and the square root of 4 is 2, a difference of squares just says, they're both 2 and they're both x. And in order to multiply to a negative 4, one would have to be a plus and one would have to be a minus. In which case, now it's a lot easier to see that if you set them equal to 0, you will get 2 answers, a negative 2 and a positive 2. I have no idea why you would want to use quadratic formula on this or completing the square. It's just not worth it. So, next up, 9, 54, and 81. That looks like it's going to be a pretty ugly problem. Except it's actually not. Remember up here a little tiny bit ago, all of these were divisible by 3. Turns out same thing happens here. They are all divisible by 3, but even better, they're all divisible by 9. And if you divide that out, you get x squared minus 6x plus 9 equals 0. And yay, it's just a regular x squared. So you look for numbers that multiply to 9 and add up to negative 6. In this case, multiplying to 9 would be, 1, 9, or 3 and 3, and this one's going to be pretty obviously 3 and 3, or specifically negative 3 and negative 3. So you get x minus 3 times x minus 3. So you get x equals 3 twice. You only need to write it once because you get the same number. When we completed the square, we used to just write x minus 3 squared, since, it's the same thing multiplied by itself. In which case, once again, you just get that one thing of x equals 3. 8x squared minus 32. Once again, you can divide both these sides by 8. You get x squared minus 4 equals 0, which, is the exact same problem we just did up here. So for the exact same reasons, you are going to get x equals negative 2 and x equals 2. So even problems can look different. They can still sometimes be the same. Next up, in this problem, it has to be equal to 0, so we'll add x squared to both sides. You get x squared plus 10x plus 21 equals 0. So if you want to try and factor it, you would look for things that multiply to 21 and add up to 10. So either you know it or you don't. If you do know it, then you know that it was 7 and 3. If you don't know it, then you could use completing the square, or you could use quadratic formula. I'll tell you right now, since it factors into x plus 3 and x plus 7, your answers are going to be x equals negative 3 and x equals negative 7. But because I like being different, I'm going to do it a different way. Let's practice completing the square. Completing the square, if you start with this, the formula for completing the square is b over 2 squared. What you do with that is you take the x squared plus 10x, but you're going to put like 2 blanks and then plus 21 equals 0. So it's just putting 2 blanks there, the x squared, the 10x, the 21. Whatever b over 2 squared is what goes in those blanks. So in this case, it's a 10 over 2, which is a 5 squared, which is 25. So this would be plus 25 minus 25 to balance it. And if you group these together, it is always going to be a perfect square. In this case, it'll be x plus 5 squared, because 5 times 5 is 25, and 5 plus 5 is 10. So minus 25 plus 21 equals 0. You put those together. Negative 25 plus 21 is a minus 4. You then need to move the 4 over, so you would add it. So you get x plus 5 squared equals 4. And from there, you would square root both sides. And I'll just bring it back to up here. So you get x plus 5 equals, please remember again the plus or minus when you square root both sides. So it'll be, the square root of 4 is 2, but it'll be plus or minus 2. And if you subtract 5, you get x equals negative 5 plus or minus 2. Just keep in mind, you can actually do this. It's not like 5 plus root 2, which you can't actually do. You can actually add negative 5 and 2. Negative 5 plus 2 is negative 3. Negative 5 minus 2. Negative 5 minus 2 is equal to negative 7. So those are your two answers, which, I already told you earlier, but there you go. Completing the square, it works. It gets you the same answer. It's just factoring is a lot faster. It's not wrong. All right. The next couple, I'll try to do relatively quickly because this video is getting pretty long. You add the 12x over, you get x squared plus 12x plus 32 equals 0. Look for things that multiply to 32, add up to 12, so that's 1 and 32, 2 and 16, 3 does not go into it, 4 and 8, and look, it's 4 and 8, 4 and 8. So then you get x plus 4 and x plus 8. You can do that because there's no number in front of the x squared. So you get x equals negative 4 and x equals negative 8. If that was too fast, then just pause it and go back. This one, 4x squared, add that over to get 3 plus 3x, subtract that over to get minus 7. So now it's equal to 0. This is, once again, factorable, or you could use quadratic formula. I'll just factor it because I love factoring. It's just what I do. 4 times 7 is 28, so you get negative 28. Up there you get 3. So you got 1 and 28, 2 and 14, 3 does not go into it, 4 goes into it 7 times, 5 does not go into it, 6 does not go into it, and 7 we're back where we started. So the one that'll get you 3 is right here. That would be 7 minus 4 is 3. So 7 minus 4 is 3. Put those x's there. Because there is the number in front, you have to do the 4x squared. The minus 7 equals 0. But the 3x gets split up into 7 minus 4. And then when you group, here you can pull out a GCF of x. And here, because this one's negative, you do want to pull out a negative 1. And when you pull out a negative 1, that does turn this positive and will turn that positive as well. So you get x minus 1. Excuse me. Motion sensor lights really suck. So you get x equals 1. And x equals, you would subtract 7 over and then divide by 4. There you go. There you go. That is the answer to the front page of these notes. I'll get to the next page in the next video. Have a good one.